Have you ever wondered what makes building massive bridges over water so much more difficult than constructing buildings on land? Every day, millions of people cross enormous bridges without giving a second thought to the incredible engineering hidden beneath them. Unlike buildings, which carry a mostly constant load, bridges must withstand millions of tons of moving weight every single day. As cities continue to grow, bridges and flyovers become even more essential, especially those built across rivers, lakes, and oceans. Constructing a bridge on land is already a complex engineering challenge. Building one over water is far more demanding. Every measurement is calculated with extreme precision, often down to the millimeter. A tiny error can result in catastrophic structural failure, costing billions of dollars and potentially thousands of lives. Whether it's a skyscraper, a house, or a bridge, every structure depends on one critical element: its foundation. Without a solid foundation, no structure can survive. But here's the real question. When a bridge stands over deep water, its foundation must be built beneath the surface. So how do engineers construct massive foundations underwater? How do they work beneath powerful waves and thousands of tons of water pressure? And how do those underwater foundations remain strong enough to support an entire bridge for decades? To begin any underwater construction project, engineers first study the site in detail. They measure the depth of the water and examine the condition of the seabed to determine whether it's rocky, sandy, or made of soft soil. Professional scuba divers often descend to the ocean floor to collect critical information. This investigation alone can take several weeks. If the water is shallow, construction becomes much easier. But if it's deep, the risks increase significantly. Worker safety becomes a major concern, while both construction costs and engineering complexity rise dramatically. Once all the data has been collected, engineers face the next major challenge: removing water from the area where the foundation will be built. Regardless of how deep the water is, the construction zone must be isolated before work can begin. One of the oldest techniques is called a cofferdam. Engineers surround the construction area with massive amounts of earth until the barrier rises above the water level. Once the area is enclosed, the trapped water is pumped out, creating a dry workspace for construction. However, this method isn't always reliable. The surrounding soil can become unstable, and strong water pressure may break through the temporary barrier, flooding the construction site and putting workers at serious risk. To solve this problem, engineers often replace soil barriers with interlocking steel sheet piles. These steel walls are driven deep into the waterbed using heavy machinery, creating a far stronger enclosure. After the foundation is completed, the temporary steel walls are removed. Another method uses large prefabricated foundation boxes known as caissons. These enormous hollow structures are built on land and transported to the construction site by specialized ships. Since they're hollow, they naturally float on water, much like an empty container. To keep them from floating, engineers first prepare the seabed. If the water isn't extremely deep, massive rocks are placed on the ocean floor to create a stable base. The caisson is then carefully lowered onto this prepared surface using powerful cranes. Finally, concrete is poured inside the structure, making it significantly heavier and permanently anchoring it in place. But what happens when the water is too deep for this method? In that case, engineers rely on another solution known as battered piles. Massive steel piles are transported to the construction site by ship. Each pile weighs thousands of tons, making it impossible to push into the seabed using ordinary equipment. Instead, enormous hydraulic hammers mounted on specialized platforms repeatedly strike the piles, driving them deep into the ground until they reach a stable layer beneath the seabed. Once installed, these piles become incredibly secure. Even powerful ocean waves and severe storms cannot shift them by even a single millimeter. With these foundations complete, engineers can finally begin constructing the bridge above. Although the process may sound straightforward, it's anything but simple. Building bridges over water requires years of planning, advanced engineering, enormous financial investment, and the dedication of thousands of workers. Some of the world's longest bridges demonstrate just how remarkable modern engineering has become. At number 10 is the Richmond-San Rafael Bridge in the United States, completed in 1978, stretching approximately 36 kilometers. At number 9 is China's Zhuhai Metro Bridge, completed in 2017 with a total length of around 37 kilometers after more than 13 years of construction. At number 8 is the Lake Pontchartrain Causeway in the United States, completed in 1956. Measuring roughly 38 kilometers, it has long been recognized as one of the longest bridges built over water. At number 7 is China's Beijing Grand Bridge, completed in 2010, extending approximately 48 kilometers. At number 6 is another massive bridge in China, measuring nearly 55 kilometers in length. At number 5 is China's Weinan-Weihe Grand Bridge, stretching around 80 kilometers. At number 4 is the Kunshan Grand Bridge, also located in China, with an incredible length of approximately 106 kilometers. At number 3 is the Tianjin Grand Bridge, completed after 4 years of construction and stretching roughly 113 kilometers. At number 2 is another engineering marvel spanning approximately 157 kilometers. And at number 1 stands the world's longest bridge, located in China. Completed in just 5 years, this extraordinary structure stretches approximately 165 kilometers. More than 10,000 workers were involved in its construction, with a total project cost running into billions of dollars.